Okay, dear friends, I'm sure all of you are there, and now we are solving one of the paper six, and this is uh, paper six, variant one for IGCSE physics, May June 2017. Time allowed 1 hour. In other words, 60 minutes are there, and the marks for this paper as a whole are 40. So, how many marks are there in total? So, this is some paper where we have a bit relaxation in terms of marks and time. So it is, but on the other hand, it is only 20% of the curve, let me say. Anyhow, so let's start from question number one. The class is investigating the stretching of a spring. The figure 1.1 shows the spring and LO, original length, and this original length is the length of the spring when no load is attached to it. When no load is attached to it. So that is the original length. Then now on figure and 1.1 measure the length LO, record LO in the table 1.1, and load is when the load is 0.0 Newton. So we have to measure it and we have to write it into the table, and we will measure excluding the hooks. Hooks will not be measured in this question. Hooks will not be taken in account. Just wait a minute. So here it is 1.5 centimeters almost. Yes. So let's see what is the unit in the book table. Yeah, it is in millimeters. So 15 millimeters. 1.5 means 15 millimeters. Then explain why LO is not measured to point X on the spring. To point X. X mean actually he's asking why in the length of the spring hooks are not included. When we will attach the load, only the coils of the spring will extend, the hooks will not extend with load. So that's what I'm going to write. Hooks hooks are not stretching. Hooks are not stretching with length, with load, sorry. Stretching with load. If hooks is not a good word, we can say rings even. Rings are not stretching with the load, so that's why we have to measure this extension when we are attaching the load to this. So that's why if the hooks are not stretching or rings are not stretching, so no need to include their length into the measurements. Student hangs 1 Newton load on the spring. He measures, he records the new length L of the spring, mean stretched length. He repeats the procedure using the loads of 2 Newton, 3 Newton, 4 and 5 Newton. The readings are shown in table 1.1. So load is in Newton, length is in millimeter, and different lengths are given. So describe one precaution that you would take in order to make reliable readings. You know, reliable readings, we are here measuring ourselves simply the length. So view the scale perpendicularly. View the scale of rule at 90 degree. That is better to write. If anybody is having any question at any moment, please feel free. at 90 degree. Then of course plot a graph of length in millimeters on y-axis, length in millimeters on y-axis, and load in Newton on x-axis. And again I'm saying in new papers they are doing one tactics. They are not saying that measure the, they will say plot a graph of L on y-axis and load on x-axis. So don't write only the symbol of the physical quantity, also write the symbol of the unit, which is millimeter for length and Newton is for load. So we can start it from 0, 0, 0, and load is 1, 1.0, 2.0, 3.0, 4.0, and 5.0. So this is more than half of the grid is covered with the data. Then our values for extension are from 15 to 25. So I cannot go 10 like this, so 0. I can then make it 5.0. This is 10.0. This is 15.0. Here it is 20.0. Then here it is 25.0. And you can check the data is spreading on more than half of the grid on x-axis as well as on y-axis. So we are now capable to score first mark for labeling it accordingly and second mark for spreading the data on more than half of the grid provided. Next is now we have to plot the points. You can plot the point in three ways, either dots, in circles, or crosses, without circle, or plus sign even without circles. So here we are going to write now see 15, 17, 20, 21, 23, 25, these are the loads. So at 0 it is 15. So what can I do? See, this is 0 Newton, so 15 I am putting a cross here. Then at 1 Newton it is 17. 1 Newton 17, so 17 means, see, this is 15, this is 16, and here this is 17. Why? Please see the one small square here, my dear friends, we can make like 25 minus 20, or even 5 minus 0, or even 15 minus 10. The difference of the two consecutively marked values on y-axis over the number of divisions. So between 20 and 25 number of squares are small squares 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So divided by 10, it means each small square is equal to 0.5 millimeters. So two small squares will be equal to 1 millimeter. So that's why 17 is 4 boxes above 15. Then at 2 Newton, the value is 20. At 2 Newton it is 20. So 2 and 20 is here. So again put a cross there. Then at 3 Newton it is 21. 3 Newton 21. So this is 21. Then at 4 Newton it is 23, and at 5 Newton 25. 4 Newton 23. So see, this is 21, 22, this is 23, and at, no, not correctly done, 23 here, and at no, 23. So here 1, 2, 3, actually here this is 23, and then at 5 Newton this is 25. So over here. So now these are the points which we are supposed to plot. So at 2 it is 20, at 1 it is 17. Okay, this 20 is looking little bit out of the way. Anyhow, so these plots are done, and now we will be plotting or drawing the line, and line of best fit we can go here. So my dear friends, here we can make it. this way, that's okay. So that is the line of the graph. Now a student suggests that the length of the spring is directly proportional to load. State whether your readings support this suggestion. Justify your answer to the graph line. So answer will be no, because graph line is not passing through origin. Use the results to predict the load L that would give a length L twice the value of LO. Twice the value of LO. Now LO, original length, is 15. Twice its value, it means 30. And where is 30? That is on here, that is here. So we can write here 30, and it means we need to stretch this graph further. We need to do it, stretch it further, so that we can get the numerical value of load there. Like this. And now see, they said, see, again read it, please, very important. Use the results to predict the load that would give a length L twice LO. LO is 15, so twice means 15 times 2, that is 30 millimeters. So we got first 30 millimeters. Now see, Alatul, this show clearly on the graph, and it is still here. Then come down this way. This is basically this 1 point. So let's see, this is 6.0, this is 7.0, and this is 8.0. So what is this value? 7.1, 7.2, 7.3, 7.4. So my dear friends, the load here, it will be 7.4 Newton. It will be how much? 7.4 Newton. And so answer, correct answer, our answer is correct, because when I'm checking it through the mark scheme, it says answer any answer from 7.2 to 7.8. So our answer is within the line. But if any one of you is having any question here, any query here, please feel free. You people can ask me now. Please feel free. You people can ask me now. If there is any question or doubt, graph was actually up to here. But then rest we need to do for the last part. We need to stretch it. Because when we are taking 30 millimeter length, so this is, and we have to show something working on the graph, so we will go this way. Anyhow, any question, please feel free. You can ask me. Okay, let's move to the next question then. That is light. The class is investigating, okay, Muhammad Tariq, the refraction of light passing through a transparent block. A student is using optic spins to trace the path of the rays of light. Figure 2.1 shows the student's ray trace sheet, and this is in front of you. A, B, C, D, and pin P3 and P4 are marked. I sign is there. Let's read the instructions. On figure 2.1, draw a normal at the center of the side AB. Label this normal. First of all, it should be at the center of the side AB. Label this normal NL. Label the point E where the normal line crosses AB. Label the point M where it crosses CD. So wait, let's go back here. First of all, let's measure the length of this AB side. When I'm measuring it with a ruler, it comes to be 8.2 for me here. So if it is 8.2, so 4.1 is the central point. So here we will draw a normal NL. Straight line, its name is NL. Where it crosses side AB, label this as E. Where it crosses CD, label it as M. If I'm wrong, let's see it again. But don't forget to write these alphabets. So label the point E where the normal crosses AB and label the point M where it crosses CD. Okay. Draw a line above AB to the left of the normal and at an angle of incidence of 30 degree to the normal. Label this line FE. Label this line FE. It is above AB, it is to the left of the normal and angle of incidence 30 degree. See, it means here FE. And we have to call it what? FE. E is already there, the other end will be F. Now what will you do? How you will be doing it? We will be using a protractor, and how we will be placing the protractor for this purpose? See, I told you many times like this, such that the center of the protractor will be at E because we need to draw the angle at E. And here will be written like 0 and 180. So you will start reading 0. So 10, 20, 30. So roughly I am doing right now this line. I'm not using the protractor, but you will be placing the protractor the same way and then start reading from 0. The baseline of the protractor, which is connecting 0 to 180, that should be on this normal, and center of the protractor should be at E. And 30 degree roughly, my dear friends, it will be something like this. Okay, so this is E and I'm writing here F. Why I'm writing here F? See, it is mentioned here again. Draw a line AB to the left of the normal. Draw a line above AB to the left of the normal at an angle of incidence 30 degree. Label this line FE. E is already marked, so other end of the line will be F. Now, and let this angle is 30 degree and it is with the normal, of course. Then next is, you can read this all statement. Right now I'm not reading it. I will just be proceeding from here. Draw a line joining the positions of P3 and P4. These P3 and P4 positions are given. Continue the line until it meets the normal. Label this point K. Until it meets the normal, label this point K. So no worries, this is now repeated stuff. By the way, we have to join P3 and P4 and it should join the normal, and we will label that point as K. So first of all, let's check. No, it's not workable here. It means a little bit down. So now still no. Okay, so from here this way. Okay, and we have to label this point as what? K. Measure and record the angle alpha between the line joining the positions of P3 and P4 and Km. So where is alpha? P3 and P4 and Km. This is the angle alpha. So we need to measure it by making use of the protractor, and again you can keep the protractor. Now flip it the other way around, such that the center of the protractor is over here and this side 0, 180 now. So start reading from 0 and measure till here whatever is the angle, and that will be the angle alpha. That will be the angle what? Alpha. So it looks to me also 30. So I'm writing there value of alpha 30 degrees. But you have to measure it. Measure and record the length x between points M and K. X between points M and K. M and K. 2.2 millimeters. So I can write here 2.2 centimeter, 22 millimeter. Why? Because I can see they have given already millimeters, so I will go with the same unit, millimeters. Then notice it is so much important to label the alphabets as they are said. If I'm missing K or M, then I will be struggling how to measure, where to measure between K and M. But as I was drawing and according to the instructions of the examiner, I was labeling the corresponding points with the told alphabets. So Km we can measure from here till here. In general it is in centimeters, but this time the answers they have given us here a clue that x is in millimeters, so we will also write here x in millimeters. The student repeats the procedure with an angle of incidence 50 degree. His readings for alpha and x are shown. Alpha is 52 and x is 19. Now a student suggests that alpha should always be equal to angle of incidence. State whether for the results support the suggestion. Justify your answer with reference to the values of alpha for angle of incidence 50 and angle of incidence 30 and 50. So when angle of incidence was 30, alpha is equal to 30 degree and angle of incidence was also equal to 30 degree. So yes. And when angle of incidence was 50, alpha is 52. So you can say yes. And within the limit of experimental accuracy. Now the question is, 1 is equal. What about 50 and 52? I told you many times. You can calculate percentage error, and the way is method is 2 times the difference in values 52 minus 50 over the sum of the values 52 plus 50 times 100%. Please all of you pick up your calculators and tell me the answer. How much percent is this? If your answer is less than 10%, so it in our IGCSE syllabus, even it is mentioned into the syllabus for 2023 till 2025, and even the new syllabus is published from 26 to 28. Percentage error in these experiments we can take up to 10%. Yes, within the limit of experimental accuracy. So how to do it? 2 times the difference in values in numerator over the sum of the values in denominator, then times 100%, and we are getting this answer. And right now it is how much? Right now it is so now here answers are there given by students. So 3.92, 3.9, 3.92, 3.94%. So let's make it roughly equal to 4%. So if it is 4% error, it means our answer is 96% accurate. So it is 4%. So we can easily write here yes and within the limit of experimental accuracy. Now suggest one precaution that you would take in this experiment to obtain reliable results. So this is a recall memory. View the bases of the pins so that pins are vertical. Pin spacing should be at least 5 centimeter. Then use sharpened pencil, or you can say thin lines. Many answers are there even, and you can find many of them in the paper 6 key points which I have provided to you people. So right now I will say draw sharp lines, sharp, or you can say thin lines when you are drawing them, plotting them. So that is enough for this 1 mark question. Yes, my dear friends, if there is any question or query, please feel free. You people can ask me right now. Okay, stay blessed, and the next questions inshallah in the next recording. Stay blessed.